Good evening. I wanted to say thanks to the BSides Organizing Committee for inviting me out here and allowing me to present to you. My name is Adrien de Beaupre, and a little bit about my topic, making pen testing analysis sexy. The sexiest part of pen testing is the analysis, creating the report, oddly enough. So penetration testing is all about telling a story of how you either did or did not break into something. And a little bit about myself, I have a large number of certifications. I'm a junkie. I work for myself. I'm a penetration tester. And I've had the privilege of working with SANS quite extensively for the past 13 years, particularly as an SANS Internet Storm Center handler. So that's probably the prerequisite about me slide. I've been using computers for well over 32 years. A friend of mine went to England in the early 80s and bought a Sinclair from Mr. Sinclair, and we assembled it. That would be a little over 32 and a half years ago. I've been a consultant for 22 years, and the past 13 years I've been working in information security. I was one of the contributors to the OSTEM 3, the open source security testing methodology manual, Hacking Exposed Linux 3rd edition, the SANS incident handling guide step by step, the 401 class, Security Essentials, I wrote part of that class, and I teach for SANS quite a lot. About 1 week in 4 I teach for SANS, particularly the pen testing curriculum. I'm a red team guy. I do teach blue team classes like 401 and 503, but it's not really my thing. When I embarked on this project to write this particular tool, I did a survey of a lot of the tools that were out there that I used quite often and wanted to make sense of the kinds of outputs that the tools gave me. Because often the tools were output in asinine formats like PDF. What the heck do I do with a PDF? I can't do anything with that. Or an HTML file. Well, HTML files are pretty, but they don't make any sense as an output format. So for example, Paros, I used to use it as a pen testing tool for web apps many, many years ago, and I hated it. Not because it didn't do what it wanted to do, because the output format was HTML. So when it was forked into a product called Zap, the Z attack proxy, I went to the guy and said, hey, fix the report format. They go, oh, what a good idea. Why don't you do that? So I did. Same thing with Nikto and Watcher and a bunch of other open source projects. And I'm a black belt in Goju Ryu, Okinawan Karate. So that's probably enough about me. So I'm going to talk about penetration testing. I'm going to define it in very specific ways, how I understand it to work, the types of things that I do, the methodologies that I follow, the workflows I follow, and how to create reports, some of the issues with some of the tools that are out there, some of the issues with the methodologies, and some of the issues with how the workflow has to work around the tools, not the other way around. Solutions and a demo, and then I'm going to wrap it up. So definition, a vulnerability is something that allows me to pwn your system. It used to be yours, now it's mine. You still provide the power, you still paid for the system, but everything other than that, from the platform on up, is now owned by a penetration tester. A lot of these terms are used interchangeably. There's no industry standard for these terms, which is a problem, industry-wide for a lot of things. For example, when I say penetration test, I mean I break in. Other people understand penetration test to mean, well, they run a tool. But the tool doesn't break in. When I break in, it's me breaking in using the gray matter, the stuff between my ears. That's how I break in. That's how I perform penetration testing. So correctly done, a penetration test involves performing a vulnerability assessment, identifying all the vulnerabilities that may or may not exist within a system, and then exploiting them. So if I exploit something by circumventing its security features, I may want to access functionality in an alternate way. For example, bypass authentication, bypass authorization functions within an application. Or I actually can invoke or access alternate functionality, things that the people who designed or even wrote the system did not expect. Clear examples, for example, in an application, if you're supposed to log in to do something and you don't have to log in, you can just invoke that functionality anyway, that's a bypass. The other thing to think about is, well, if the application that's running in a car can control the car, and I can invoke it using alternate functionality to make the cars do things that they weren't supposed to do, the engineers did not design that functionality in there, that's a pen test. So most often, penetration testing done correctly is also goal-oriented. For example, I'm told, Adrien, break in and get PII, get personally identifiable information, or break in and get all the credit cards. There's usually a very specific goal. If you tell me you need a pen test and can't articulate why you need one, the results may or not be what you expect. One of the things about pen testing is that you have to remain either in scope or within your rules of engagement. Actually, it's not an or, it's an and. You have to remain within scope and within the rules of engagement, which is quite awkward in some cases because the bad guys don't have to do that. So if I'm trying to model or emulate what a bad guy would do, what a bad person would do to your environment, you put rules on me that limit what I can do, limit my actions. So for example, you might say, okay, social engineering is out, wireless is out, web applications and network is in, but social engineering and, oh, I already said that, and client-side exploits are out. But that's exactly how the bad guys are going to think. They're going to think of, well, where are you really vulnerable, and then attack you that way. So there's no really such a thing as cheating in pen testing. As long as I remain within scope, remain within the rules of engagement, anything goes. And I often have clients say to me like, well, how did you manage to do that? And half the time it's, well, I just logged in. And you say, well, Adrien, is that pen testing, just logging in? Yes. Penetration testing is I can invoke functionality or access functionality I'm not supposed to be able to do. And if I can do that just by logging in as someone else, that's fair game. In fact, it's the most common way of actually achieving a pen test is I guess usernames and passwords, or I steal them off the wire and I just log in. So one of the interesting things about doing a pen test correctly is that it requires methodology, it requires creativity, it requires being methodical and thinking, doing analysis about how do I break in. It's, to me, the sexy part of doing pen testing. The other part of why I call this my sexy presentation is because everyone comments on my slides. They're dead boring. They're meant to be dead boring. They're just words. People commented on the old title for this particular presentation. It was Security Automation and Analysis for penetration testing. People said, well, that's just boring. So now I've spiced it up. As you can see, it's now the sexy presentation because the sexy is in the title. So when you're doing a test, there are very formal rules about testing. You provide a stimulus, you expect a response, and you monitor. If your monitoring fails, you cannot gauge the effectiveness of the stimulus to produce the response. If the stimulus does not produce a response, that may be the expected result. However, it may not be. So your test might be ineffective or of no value. Each test is a module. The modules should expect as an input the output of the previous module. So for example, one test may be, is the system available for testing? Can I ping it? For example, the expected response is I get ICMP echo request, ICMP echo response, and away we go. If I cannot perform that test, there must be something wrong. So the inputs and outputs must be expected and planned. This is where a lot of pen tests fail. Where a pen test is, you open tool, whatever tool name it is, doesn't matter really, and you fire it away and just expect results. Because people ask me, Adrien, what tools do you use? Well, I use the same tools as everyone else. It's no surprise. There's no hidden magic to it. We all use the same tools. We all use the same methodologies, even though some of us lie about it. But the thing is, it's not about the tool, which is why you get differing results from different pen testers, because the real thing is the creativity, the analysis, the brain power, because we all use the same tools. So testing must be appropriate to target. I've seen testing results come out of, for example, common criteria assessments, where the common criteria assessment requires a pen test be done. And I've seen devices that do not have a network stack, and they show me Nessus results as part of the common criteria assessment. I look at it and go, what were they thinking? It's not a network device. It does not have an IP address. So of course there's no results in the Nessus report because I don't even know what they pointed at. So here's my methodology. It is not precisely from the OSTEM. It's not precisely from the pen test execution standard. It's more of a blend of a lot of the standards I've seen out there. It's one I've followed for the past 13 years, as I mentioned. It starts with logistics and planning. Can I do the test? We go into information gathering and reconnaissance. So the first three steps are the ones where people fail the most, honestly. And then the last step, the reporting, the analysis, is where they fail the second most, if that's possible. Everything in between is easy, because most of the tools can do this for you, right? In fact, you fire up Saint or Core Impact or Canvas. It does a lot of that stuff in the middle for you. But following these steps in the methodology and applying the analysis, your brain power at the appropriate point, that's the key point that people fail. So I could call this talk, Why Pen Testers Suck, right? To quote Marcus Rantum, if the pen tester breaks in, you suck. If the pen tester does not break in, the pen tester sucks, right? No. It's all about how do I achieve the goal of demonstrating risk. So one of the things we do is open source information gathering called OSINT. Open source not as in RMS, Richard M. Stallman, but as in how do I find out information about you on the internet? Not what you know about you, what other people can find about you on the internet. We basically use Google hacking. So the types of inputs we get are, for example, the organization you work for, the type of industry you might be in, or the type of government you work for. And we just go crazy finding information about you. So all this stuff, for example, resumes are awesome. People who used to work where you work, their resumes are invaluable because I can determine exactly what kind of infrastructure you have. I can determine exactly what kind of technologies you use, just based on resumes, or the types of people you're looking to hire. That information is gold. I know exactly what you're using, exactly what technology you have, without sending any packets from me to you. Always works, never fails. The type of data I get out of open source intelligence gathering is free-form, for the most part. There are some structured tools in this area. For example, ReconNG or FOCA are very useful here. Reconnaissance. This is essentially which systems or which targets from the internet-facing systems might be live. Things I look in are who is, looking at rn.net, looking at your DNS records. I will find out invaluable information about your systems just by poking around. Again, no packets necessarily have to go from me to your network. So for external pen testers or contractors, consultants, we often do these first two steps prior to contract engagement, prior to actually inking the contract, because I'm not attacking you. I'm just gathering information. It's fair game. So I do a lot of things, for example, ping, nmap, IKE scan, fierce domain scanner, traceroute, ICMP. There are a lot of tools I will run to determine which systems are live in your environment. This works either across the internet or for internal environments. I find that when I go to an environment, I ask them, okay, so what documentation do you have? Can I see your network diagram? And I often get, the deer in the headlights look. What diagram? We don't have one of those. So oddly enough, sometimes in some environments, the best documentation they get is from the pen test report, which is kind of sad, right? Because I actually know where all the systems are. Now the types of outputs from a lot of these tools are much more precise. They might have structured data output formats like XML. I'm going to come back to XML quite a bit because it's my preferred output format. I can write a script that can understand XML and do things with the output. Remember, one of the key things to testing is the output from one module is the input to the next. Some of the automated pen test tools do all that stuff for you. They make decisions on your behalf at the input points between the methodology phases. And I don't like that. I prefer to stop and perform the analysis. I automate everything else, but the tool should not make decisions for me. So identification, enumeration, again, all kinds of other things, like for example, what ports are open, what operating systems are there, what services are listening behind ports, what protocols are available, is it dual stack, for example. Nmap, of course, is one of the primary tools here, Nessus. So again, structured output formats are my friend. They help me manage the data. I'm going to show you how we do that later on. Research. This is the key step. For example, if I take nmap with the NSE scripts and just run them, I get information about the system. I can, for example, enumerate vulnerabilities on your system, which is great. I have a structured output format in XML. But what I really need to do is take the information I've gathered up to this point and identify vulnerabilities just by Googling, just by looking up in databases. This is effectively what a lot of the automated tools do. They're basically nmap with a database of known vulnerabilities. In fact, some of the automated scanners actually license nmap code. But what's interesting here is I can identify vulnerabilities that the tool might not be able to, because I know information that the tool does not through the earlier phases, through the open source intelligence gathering, for example. So when I identify vulnerabilities, here's one of the controversies in the industry. People say, oh, false positives are bad. I disagree. In fact, I don't want the tool to remove findings from its database. I want it to tell me everything. I want me, the analysis. The analyst does the reduction of false positives. So I want the tool to tell me everything it knows, including the things that are wrong, because I should be able to exclude what I know to be incorrect from the database. This is a key thing that is missing from the tools, because they're all about false positive reduction in the tool. I disagree. Because the real problem is not false positives. They're just extra work. The real problems are false negatives, things that the tool cannot identify. This is the real boogeyman, the real problem with this entire industry. So we're going off on a different rant for a second, probably more than a second. There's an entire industry out there called Crappy Pen Test Incorporated. Shouts to Ed Scotus, that's his term. Crappy Pen Test Incorporated basically will do your pen test for you, but they will not give you any findings. And you're happy with that because you get to pay them money. They get to pretend they ran Nessus or Nexpose or whatever other tool. They pretend to give you results, but there are none. Because you didn't want any. Because you had to do a pen test for compliance reasons. Think about that for a sec. There's an entire industry willing to take your money, call it a pen test, and not actually do anything. Well, they'll send some packets, obviously. Now, these are the tools we use. They're not, unusual. Nessus, Nexpose, Burp, W3AF, Zap, Scapy, Sully, and reverse engineering. So the real interesting part for me of vulnerability identification is not necessarily just false positive reduction, false negative identification, and the identification of previously unknown vulnerabilities. This is the great thing about web apps. I love web apps. I've never found a web app I didn't like. I love them all. They love me back. Right? You see Hacker Safe or Scan Alert, a logo on the website, and you just pop all the, you pop all the credit cards out or pop all the social insurance numbers. It's great. I love it. I always try and get their logo into the screenshot. Because I'm mean. So one of the things about web apps is that there are entire classes of vulnerabilities in web applications, for example, SQL injection or cross-site scripting or cross-site cross-forgery. But for every piece of custom code, every day I find a 0 day in a web app. If I find a vulnerability in SendMail or in the SMB service in Microsoft Windows, every instance of SendMail or Microsoft Windows will have that vulnerability, which is great. You can sell that for gajillions of dollars or be rich. Depending on how ethically flexible you are, you can be rich. But really, finding new vulnerabilities is quite amazing, and one of the biggest problems in this industry, other than contracting legalese and lawyers, is really the fact that non-disclosure agreements are almost always required. So I cannot tell people about vulnerabilities I know exist in gear they run, because I've signed agreements with other companies that I cannot talk about that, or government agencies. So the outputs from a lot of these tools are primarily structured data, like, for example, XML files. They might be CSV files, but we also find that some of these automated tools have their own back-end databases. So effectively what we do is we break into the back-end database and run queries against it directly, because I don't care how pretty the reports are. I'm all about the data. When I'm doing a pen test, I'm all about data, data management, or shell. That's what I want, right? I want shell. When I get to validation exploitation, I have in some cases called a vulnerability assessment a pen test. Sometimes I call a pen test a vulnerability assessment. I will probably call it whatever you want as long as it's in the contract and you're willing to pay me, right? So if you're willing to pay me to call it a pen test when I know it isn't, I will put language in the document that says, well, it's not really a pen test, it's just a vulnerability assessment, based on the types of things that I do. But when you get right down to it, this is the point where the rubber meets the road for pen tests, because being able to demonstrate risk is, I broke into system A in your DMZ. I then pivoted through that system into a separate DMZ into the backend database. I then pivoted through there, collected all the usernames and passwords, logged into your internal domain controller as domain admin before lunch on Monday. This is my objective. I control your domain from the internet through your web app. And you might find that surprising, like, Adrien, are you really that good? Actually, no, I'm not that great. I'm pretty good for a pen tester. It just demonstrates how bad web apps are. It's not just that they're badly configured or badly coded, but they're badly architected. Why on earth Should someone be able to talk to the backend database for SQL injection, grab passwords, and then log into the Active Directory domain? Should never happen, right? Just architect it differently. So that's what a true pen test does. It identifies issues not only in the code, but the overall infrastructure in people, process, technology, right? There's only 3 ingredients to any project: people, process, technology. So these are the tools we use. Our, of course, real objective is pwnage. You know, what I really want to do in a pen test is laugh hysterically. I giggle. The clients call me and say, "Adrien, how are things going?" And I laugh. I say, "I'm having an awesome time." And they go, "Oh, good." And I said, no, good for me, not so good for you. I'm having a great day because I'm all over your environment, right? And people think that's mean. You know, this is my entire business model. I come to your environment, I break all your stuff, and then I leave before I have to fix anything. Give you a report, and then you send me a check. This works for me. So the output of validation exploitation is also more freeform. For example, some of the tools may grab a screen capture of a desktop, or I may log in and grab a screen capture, but a lot of the output formats are basically a check mark saying, yeah, that exploit really worked. That was awesome. Beauty. So, penetration. When you penetrate an environment, the key thing is pillage. Do not forget to pillage. I've seen this time and time again. One of the things I look at, for example, is I look at previous pen testers' reports. And if they suck, I tell the client. So beware. If you break in and forget to pillage, you totally forgot the whole point. Right? The point is not the shell. The point is not exploitation. The point is not just breaking in. Breaking in is the start of a pen test. Once I have the first box, I'm not done. I want all of them. That's pwnage. That's pillaging. So identification of previously unknown vulnerabilities is one of the other areas we look at quite a bit. A real pen tester should be able to, get right into Ollie Debug or right into IDA Pro and identify issues, overflow buffers or heap overflows or whatever else is out there. Write ROP code. But the best hack is always the most elegant. I just log in. I'm a regular user or I'm an administrator logging in. You can't tell me from bad traffic because I'm just logging in. I'm invoking functionality I probably shouldn't be able to do, or doing things I'm probably not supposed to be able to do, but I have to have a fairly advanced knowledge of how that infrastructure, how that technology works, perhaps better than the sysadmin, which is interesting. I haven't been a sysadmin in almost 20 years. But really the tool here is the analysis, the stuff between my ears, the creativity and the methodology, being methodical and just thinking up new ways to break stuff. That's what I do, don't you? Anyone work as a pen tester? Anyone want to be a pen tester after hearing this talk? Right? Sounds sexy, doesn't it? That's hence the name of the presentation. Oddly enough, the majority of the time, it's tedious. To me, it's just like forensics. I don't do forensics anymore because there are things I can never unsee. I don't do forensics anymore. But forensics is tedious. I need to find a needle in a needle stack, right? Needles in haystacks are ridiculously easy to find. Do you know how you find needles in haystacks? With a magnet, with fire, or water, right? It's super easy. Finding the one needle that is ever slightly different from all the other needles, that's true penetration testing, that's true forensics. It's very tedious. And it's methodical. But it's also creative and fun. So it's one of those strange things that there are not that many people who do it really, really well. And we tend to know each other. So one of the interesting things that's an output of penetration is, I love that word, booty. I pillage, I booty. I grab booty, I take your booty from your systems, and I have fun with it. This is how I get my enjoyment out of life. I giggle, I sit at home, most of my work I do from home. This is the thing that people hate. Oh man, I got shell, I stole all the stuff, and now I gotta write a report. Oddly enough, because I choose to automate most of the parts of the process that I don't like doing, The reporting is dead easy once I have all the data in a format that I can just automate doing things like queries. I could write SQL. We were joking earlier about SQL. If you manage your database through SQL injection, I don't even call that SQL injection anymore. I call it SQL request, right? You know, it's funny, but it's true. And you know, people should cry, but we have to laugh instead. So writing a report is wordsmithing. It's basically running queries against a database, I'm going to talk about that in a sec, and just filling in the values. The hardest part for me of writing a report is an executive summary. I like them to be 2 paragraphs, max. 2 paragraphs, half a page. That's my executive summary. Here's what I did, here's why you should fix your stuff. I keep forgetting to not remove my filter, and I can say shit in front of this audience, right? You know, fix your shit. I've seen people cry because essentially I've told them your entire application is shit. Your architecture is shit. Throw it all out, start from scratch. They're like, but we just spent $2 million on that. Well, it's probably going to cost you 3 to fix it because it's all fucked, right? Too bad you didn't think of this before you before you wrote all that code. Sucks to be you. But the reporting is actually fairly easy. If you write it, all the findings, I write them as I find them. So I'm writing my report as I go along. When I get to the end and have to write the executive summary, it's not that hard. You know, there are meta findings. For example, you failed to code correctly. You failed to architect your environment. You failed to patch. There's really fairly limited findings to put in a report. You fail. We used to call it BF cubed, big fat fucking fail, right? That's the grade we would give our clients. So why would you automate? Well, really, I'm lazy. I was a Unix admin. Unix admins are lazy. We love CLI, right? Everything's about the command line. Forget GUIs. GUIs are for wimps. So I automate everything. I had a job where I was there 8 hours or thereabouts, and I figured out that after a little while, I could get my job done by writing 5 scripts in the first 30 minutes of my shift. So that's laziness, right? But I would spend like 10 hours writing a script that would save me 30 seconds. Because I hated typing anything twice. So I want to automate all this stuff. I've been doing pen testing for a while. My first pen test, the older gray-haired gentleman who was the pen tester at the company I worked at, I was pulled aside, said, Adrien, you're going to do a pen test. And I was like, wow, awesome. So I went over to watch. And the guy booted up Windows, and I went, huh? And then he launched CyberCop, and I went, huh? And he configured the GUI and hit go. And we watched it for a little while, and I kind of looked at him going, where's the penetration? He goes, wait for it. Here comes the report. Slightly disappointing to me back in the day. So now, if I have the ability to impart my wisdom, my knowledge, my maturity, what I really want to have is a process that anyone can do it. I will hire people to be scan person, and that scan person, all I want them to do is run this scan. When you're done, give me the results. That's fair enough. And I push scan person aside and say, okay, off you go now. So if I can engineer a process that I can push down the automation to other people, that leaves me the time to do the fun stuff, the giggling and the ponage, right? So I want to streamline, make it a more efficient, engineer a process that can be maintained by an operational group. For example, I've been hired by firms to come in and do their vulnerability management program. Above and beyond, they just bought the tool. That's a whole other rant about salespeople and buying tools that fix all your problems. Have the tools you bought fixed all your problems yet? I'm just saying, right? And to go off on a different rant, if user education was going to work, don't you think it might have worked by now? Just saying. So really, I want to automate parts that should be automated, but the parts that require analysis, I want to be there to do the analysis. Requirements. It's got to be repeatable. It's got to follow my methodology. Unfortunately, none of the commercial tools follow my methodology. They try and make assumptions for me. They try and make decisions for me. So I have to do this. I am a command line bigot. There, I said it. If it's not command line, I'm not doing it that way. People ask me all the time, Adrien, how do I do this in Word? I'm like, I have no idea. What's Word again? Right? So I script stuff. I want output from tools that I can parse or process using an automated process, and a database. You can do some pen tests in your head, right? If I have only one application to do, it's really small, or only, say, 5 hosts, all the results, I can store them in my head. Kind of. You know, it's one of the first things to go when you're over 40, is your memory, right? Not what you were thinking. Booty bang. So I want to be able to correlate multiple sources of data. For example, I have Nessus and Nexpose, for example. I ran them both for whatever reason. And I want the results to correlate between them. But they don't agree into terminology they use. They don't agree as to what they call a high, medium, or low. So I need to normalize the data. So I need to automate a process to normalize data from multiple tools and correlate between disparate information points. Not that hard. I want to have human analysis performed at certain specific points. I want to be able to provide my own mitigation. I almost never copy the solution part of the tool, whatever the tool tells me. In fact, really, a pen test, there's no part of that report that is copied from any tool ever, really. It's just not. It's all from up here. Metrics. If you ever run an information security program, you need metrics. You need to be able to say, we have blocked this many viruses, we have blocked this much stuff, we have stopped every attack in its tracks. You know, talking about APT for a sec, it was brought up earlier, the advanced persistent threat. People who deal with APT on a regular basis talk about waves, right? The waves of APT, the Chinese hordes. Now, going off on a different tangent, if you're going to source an attack, where would you source it from? China, right? Where would you bounce it through? Israel, Jordan, maybe back to China, through Costa Rica just for fun, right? Syria. Wait, do they have computers still? Right? So you need quantitative measurable trends out of a pen test report or out of your vulnerability management program. And your own severity system, whatever that is. High, medium, low works. So the workflow is basically we need modules. Output from one is input to the next. That's fairly straightforward. And I want to be able to stop the tool at each phase and say, okay, give me your results, import into your database, and then go from there. So one host I can keep in my head. 5 hosts I can write down on a piece of paper or keep it in Notepad. 50 hosts, 100 hosts, I can try using Excel or some spreadsheet program. Not really good at those old office tool things. It's not command line. There you go. So really I need a database. And the database has to be able to give me the results from more than one tool. This is a problem. So either I have to run each tool 5, 6, 10 times and stop them each point and rip out the data, or find a way to automate that process, which is not hard. So the tools don't follow my methodology. So I take output, it's a database import. Then I run a query, it's the input to the next tool. One of these days I should write a DFD, right? An actual flow diagram. Go figure. So the output of some of these parts of this process is inputs into ticketing systems, right? You've all used perhaps some ticketing system, Heat or Remedy or Peregrine, those behemoths that just truly suck on a monstrous scale. So really there's got to be a loop back. If I test stuff and I can break in, you should probably consider fixing it. Does this make sense? You'd be surprised. I've done the same pen test 3 years running, given them the exact same report. Effectively. I just have to change the date, send the invoice. It works for me. I'm okay with this, right? So the problem is my tools don't follow my methodology. I need structured data output formats. I need to be able to do something with them. I have to manage that data. If you do a large-scale pen test of a large environment, you have reams and reams. You have perhaps even terabytes of data in no time. This is a problem, finding the needle in the needle stack when you have terabytes of data. So what do? Basically, I need to design a system. So I've designed this system now 3 times. The first time I designed it, I worked for a small company called Cinnabar. We were 40 employees. We basically got together and decided, okay, we need this tool that helps us do pen tests. And we wrote it in Python at the time. The first attempt was written in Perl. We decided we didn't like Perl anymore. We wrote it in Python. I left that company, and they kept the tool. The next company I went to, I rewrote it again in Perl. The exact same concept, but with a new design. I left that company. They kept the code. This is the 3rd time around. I rewrote it again in Python and open sourced it. So now I'm just giving it away. So what's really missing is there's tons and tons of data. I need to be able to efficiently analyze it. Ideally, I should be able to go through each and every piece of data that's not feasible within a reasonable time frame, right? Because pen tests are almost always time limited. If you came to me and asked me if I could do a pen test with unlimited budget, I would do it for you. That makes sense, right? Unlimited, but they don't do that. They come to me and say, Adrien, we're willing to spend $25,000. What can we get for that? I tell them, well, you can get a pen test. It'll be X number of days. And I have to stick within that X number of days or I go over budget, and I don't want to do that. So I need to be able to correlate between tools. I want to be able to mark false positives, and if I find a false negative, I want to be able to put it in there. None of my tools let me do this. So there are some things out there that fit this niche now. For example, Dratus or some other tools. Oddly enough, all my research, all my work predates all those tools. I've been giving this talk now for about almost 10 years. There are systems out there that can do some of this, but they're either quite expensive or they don't quite meet my workflow. So solutions, I need basically a framework that manages all my tools, manages all my data, allows me to insert and run queries on a database, and it's all got to be command line, and it's got to run on Linux. So pretty much easy, right? Didn't actually take me that long to write it when I sat down and wrote it. The previous implementation in Perl was, I think, around 3,000 lines of code, including comments. The current implementation in Python is 500. I love Python. I will never, ever go back to writing Perl. I would rather scratch my eyeballs out. Honestly. You know. So for every tool, for every tool I write, or sorry, for every tool I use, I need something that can make sense of the output, normalize the data into a format that I approve of, and then insert a database. So that's basically what we're going to do. So I called it OSAMs. There are two other people in this project. One's more of a database guy. The other guy is more of a programmer, pen tester like me. And we called it OSAMs, the Open Source Security Assessment Management System. It's basically, the first thing we had to do was design the database. That actually ended up being the hard part. Writing the code afterwards to match the database took me no time at all. So this is how I do analysis. I run the tool through Python. I take the output with Python, do something with it, put it in the database, run the query in Python. How many times have I said Python? So it's a modular process. It's open source. It's out there. You can download it. It works today. So database design is key. Currently, I'm using MySQL and Linux. It's just what I'm most familiar with. I'm not a DBA, never been a DBA. None of my LinkedIn profiles say I'm a DBA. None of my Facebook profiles say I'm a DBA. None of them. So Cody, one of the other people who work on the project, writes a lot in Windows stuff, so he does a lot of PowerShell, and he's written some Perl scripts. Everything I write is in Linux and in Python. So there will probably be a GUI someday, not written by me. So it's flexible, it's extensible, it's open source, you can download it today. Here is the essential database structure. So basically, I have tables that allow me to enumerate things like hosts, like vulnerabilities, like ports, like configuration of tools, like references, and all of these tables cross-reference each other. And I can run queries based on, okay, tell me what Nessus results were imported, or tell me all the highs that were imported from Nessus, or I ran Nmap, tell me all the hosts that responded to stimulus. So the tool output table is essentially which tool was run, and information like, well, what tool version was it? Not very sexy. It's got a primary key, it's auto increment, very, very simple, very straightforward. The configuration from the tool is pretty much more open format. Some tools tell you how they were configured when they were run, other tools don't. So one of the things we run up against is that tools have wildly different output formats, and some of them truly, truly suck. No one seemed to have ever noticed that the Nikto XML format had been broken for 3 years. It didn't work. So domains, for example, is just an arbitrary grouping of systems. It could be an actual Active Directory domain, or just a grouping of systems or a work group. So it's basically I group systems together and call them a domain, if necessary. Groups might be user groups, for example, or other GPO objects that I might want to enumerate and have access to within the tool. Hosts is probably one of the most basic things. Now, of course, we don't always enumerate hosts. For example, I may be doing one pen test of an application where all the hosts are completely out of scope. So some parts of the database we use at different parts of the pen test. So for example, things I might have IPv4, IPv6, whether or not recon was performed, and whether or not the host was identified as being live during recon. For example, if I run an nmap against 10,000 hosts, there might be only 2,000 responding at that particular point in time. So for the IP addresses I ran, but did not identify them as being live, I set recon to no, or recon false. MAC address, OS, operating system information. The criticality is a free-form field. It's where I have to put in my own notes as to how critical the system is. This may come from an asset system, for example, an asset inventory database. Users is very important. For example, we want to have their hash here, and we want to have their password. Obviously, if we want to be able to log in as that particular user, we need that stuff. So I need to be able to, for example, grab results out of John the Ripper, or Kane, or other password tools. I might just write notes, like for example, this guy is a total retard. Oops, sorry, did I say that out loud? Dipstick. Inner voice, outer voice, inner voice, outer voice, inner voice, outer voice. So I keep notes basically on the things that I find, and I put those into the database, and they allow me to remember the things that I found. Because when you manage a large pen test, a fairly large infrastructure pen test, it takes a while to gather all the data, and by the time I'm done gathering the data, 5 days have passed. So I can't remember what I did Monday. It's now Friday. Ports, fairly straightforward, depending on the protocol, TCP, UDP, or other. You may actually be shocked and surprised to know there are other protocols other than TCP and UDP. So, for example, nmap will tell me which ports may or may not be open and tell me which protocol was run. It may find the banner or the service running behind that port. This is the key area, the vulnerabilities. So each tool may tell me about a vulnerability. One of my major beefs with NSC scripts is that they don't identify any other information other than the vulnerability. They just basically just say, like, well, I ran and here's the results. There you go. And I'm like, okay, well, what does that mean? Who knows? So each vulnerability, I have to normalize the data from the tool. And this is where you spend a lot of work basically deciding, okay, this tool says that it means this vulnerability. This other tool means this other thing. So we need to be able to mix and match based on references like CVE. We also need to be able to manually attribute things back to other things. Like for example, well, that says cross-site scripting. This other thing says script injection. Oh, that's the same thing. I can basically normalize that. References is a key area. For example, I might have URIs or OSVDB entries or CVEs, things that tell me what the vulnerability is, or CWEs for web applications. And this is, again, one of the things I use to correlate between tools, between different points of data. And booty. Booty is just free form. It's just fun. I just like saying that word. I don't know why. Booty. So it's just the stuff I find, you know, and it's tying it back to the goal of the pen test. This is where I write down, hey, whoops, I have all your credit cards. Hey, I have all your social insurance numbers. Or hey, I have all your health PII. So a lot of these things are written in scripts. This basic flow is I run a script that runs a tool. I run a script that takes the output from the tool, parses it into the database. I then run other scripts that will update the database, annotate entries in the database, do things like write my notes in there to reduce false positives, to do false positive reduction, to do false negative identification. I then run queries. Those queries give me results that are then the input to the next tool. And then I have to do analysis, right? This is a very iterative process. It is not always backwards and forwards. It looks as though I always flow top down. However, when I'm at the bottom doing the validation or the actual pen test and I break in, I actually have to go back up, right? I'm going back to enumeration. So the primary script, the primary area of interest here is the scripts that actually take the data from the tool and do something with it. They have to read their configuration functions. For example, I use very similar to an INI file, a configuration file. I have to either create or access the database, do things like MySQL functions. I have to either read a list of files or read a specific file or read a list of files and basically do something with them. The files can be in a variety of different formats. For example, dig will give me data, DNS information. It's somewhat scriptable, somewhat parsable with a script, and then insert that information into the database. This is the pseudocode of the entire application. These are all the tools that I have written scripts for. If you give me an output format, I can write a script for it in almost no time at all. The parsers are quite easy, so long as the output format is machine readable. So PDFs, not so much, right? It's got to be in a parsable format. I prefer XML. I prefer well-formed XML. For example, Acunetics, Beaupre, Grendel, NetSparker, so I do a lot of web application work. I just grab these tools, not at random, but because I've either had to use them or use them on a regular basis. They're in no particular good order. They're kind of alphabetical. Zap, WebSecurify, Skipfish, SLScan, Nikto, Nexpose, the other network guys. Where's Nessus? It's in there. There are a whole bunch of other tools that are out there that I will probably write a parser for at some point. So let's take a look at the demo. This is the, so I'll give my slides to Ron, and I'll have them available. I'll put them up somewhere and tweet about it. So basically, you just take nothing up this sleeve. So if I do kill the database, there's no database there. Good. Hey, portable code. It runs just fine on Windows. Sarcasm is a blunt tool. Take some Nessus data, slap it in the database. Take some Nmap data, slap it in the database. Take a GUI tool. Yes, I know. Run a query, get results. So here, for example, all the Nessus results where I have, so here's all the Nessus results, just basically grouped by host number. Here's another query I ran where I took, for example, all the vulnerabilities that were 3 or up within the entire system, and I grouped them and did a concat of all the IP addresses. So this is an easy way to demonstrate how I can just run queries against the database and get results. And let's go back here. So you can download this code today. I also wrote a Nessus client in Python, because running the GUI doesn't really work for me. So the key thing to a real pen test is not the tool. It's not the scanner. It's what you do with it. It's problem solving, it's critical thinking, it's analysis, it's being creative, it's being methodical, it's following methodology. A lot of this stuff can be done quite easily. I'm not a coder. I never pretend to be. And there are plenty of open source tools that can do things for you, make your life easy. And there's my contact information. I'm on LinkedIn. I'm on Twitter. There's my email address and any questions. I'm a true believer in if you take, you should give back. Open source has helped my career. Taking SANS courses has helped my career. So I give back by teaching and giving away for free the things that I write. I'm a very firm believer in open source. To me, it makes sense. I'll never make money off this thing, so.
How often during pen tests are you allowed to sort of hide your trash, fetch log files, and that kind of stuff? Or is it,
So the question is, if I understand it, how often am I allowed to emulate a real attacker? By, erasing logs, like being stealthy, almost never. In fact, the point being, I have very limited time. I go loud and proud, very noisy, and you should be able to see me. What's interesting is that I go very loud and noisy and people don't see me, right? They're like, did you start the pen test? I'm like, didn't you notice I was logging into your domain controllers? Well, if there are no further questions, it must all be true. Thank you very much.